Howdy! We're the Techno Tumbleweeds from Scottsbluff, Nebraska, and we're so excited to tumble into the great state of Kentucky.
As a second-year team, we set ambitious goals and focused on improvement, including learning a new coding software. Through engineering classes, Onshape video tutorials, and the experts we reached out to, we improved our CAD and manufacturing skills. Using GoBuilder, we built an omnidirectional square chassis to serve as a long-term foundation for our robots. During testing, we discovered that one drivetrain motor was moving 20% slower, causing uneven movement. We replaced the motor, resulting in smoother movement. We also wanted to optimize our initial structural design, especially the functionality of our custom-designed arm. We contacted mechanical engineer Paul Rogrodin, who recommended changing our claw design.
To create a reliable claw, we researched proven designs, combining ideas into a hybrid model. Our first 3D printed claw used a servo to spool string and a rubber band for tension, but it wasn't strong enough. Using Paul's suggestions, we developed two new designs using gears. The first was a rack gear between two angled bevel gears. After testing, we found it didn't open the claw well. The second, a servo-driven 4-gear system, allowed both sides of the claw to operate simultaneously, proving successful. Our latest iteration is using a C-channel rather than a 3D printed arm, and adding a Z-axis rotation to our claw, which allows us to pick up samples that are not parallel to the robot.
Our sample system uses 2 lift kits to reach the top basket. Our initial design used a single lift tower but was unstable, causing wobbling and driving. To improve our robot's efficiency, we plan to add a secondary arm on the opposite side or back to collect samples and pass them to the primary arm. This will allow the robot to stay aligned from the submersible zone to the buckets, eliminating the need for turning, adjusting, or waiting for the primary arm to get in position. This season, we focused on building a robot that balances simplicity and performance. We iterated our design, especially the arm, which uses a rotatable claw for faster sample placement. A hook outside the lift system allows handling while saving space. Our streamlined design handles key tasks efficiently and works well alongside more complex robots, proving that simplicity can drive success.
Goals, a fundamental component of the first program, are what motivate people or teams to constantly improve. We've had countless goals this season. Whether that be improving our outreach or expanding our hardware, we have always strived to accomplish more. This season, we really wanted to implement odometry into our autonomous. Being invited to this competition allowed us the opportunity to deepen our knowledge and expand our technical capabilities. To achieve odometry, we utilized the Roadrunner library. It allowed us to execute parallel actions by structuring our code into Java classes for each robot component. The integration of Roadrunner proved to be a game changer, doubling our autonomous score, making a force to be reckoned with on the field. Accomplishing our goals showed us that First Tech Challenge is not just about winning. It is about learning from your mistakes and striving to become better as individuals and as a team.
This season, our team transitioned to Android Studio to push our programmers to real-world coding solutions. Alongside this, we adopted GitHub for version control and integrated Roadrunner. In Teleop, we achieved an average sample cycle time of 8.8 seconds, scoring up to 119 points. We complete a level to ascend with at least 4.5 seconds remaining, including our auto. Our theoretical max score is 186 points. Our primary autonomous scores the preloaded and 3 spike mark samples in the top basket, then parks touching the low bar, totaling 67 points. Our alternative autonomous hangs 3 specimens, pushes 2 additional samples into the observation zone, and parks, scoring 63 points.
This year, we set a goal to expand our outreach and inspire others to embrace the culture of FIRST. In Scottsbluff, Nebraska, we trade traffic for tumbleweeds. Living rurally means everything is a little further away, including opportunities. Though we live in a town of approximately 14,000 people, we reached over 10% of our community. For a team of 7, that's a big number. We also impacted 108 FLL teams and hosted or participated in 20 events. We received funding from the Oregon Trail Foundation, Progress Rail, and BNC Steel this season. Within FIRST, we served as judges, referees, and announcers at 4 regional mini-play events and the Nebraska State FLL Championships. We also mentored 4 FLL teams weekly.
At one FLL scrimmage, we hosted a Girls in STEM event to inspire girls by connecting them with female mentors. We are also co-hosting 2 robotics camps this summer. In the STEM community, we collaborated with experts from our sponsor companies and taught bi-weekly robotics classes for elementary and junior high students. Our non-STEM outreach included partnering with Beyond School Bells, an after-school program to teach coding and design. We also created the Techno Tumbleweeds Teach Technology, a program helping senior adults navigate their devices. We've now hosted 4 events. One highlight of our season was sharing FIRST's impact on our lives at the Governor's Mansion. 20 Nebraska senators were represented. With the help of our community and the friendships within our team, we have enjoyed our season and accomplished our goals. Thank you.